for Math 1324. Okay, today's topics, it's over chapter 6. Okay, I'm going to cover some examples from every section, 6.1 to 6.6. Okay, so let's start with 6.1. Here it states, determine whether the given order list of numbers is a solution of the systems of equations. So what we're going to do here, we're going to plug in -1 for x and 3 for y. But it's got to be true for both equations. Okay, so let's call it equation 1 and equation 2. So first, I'm going to plug in the values -1, 3 on equation 1, which means I'm going to plug in -1 for x and 3 for y. Okay, after I do that, I'm going to evaluate the right side, so this will give us -2 plus 3. So 1 equals 1, so this one checks out. Okay, but before we can say it's a solution, it's gotta be true for both equations, equation 1 and equation 2. So now I'm going to repeat the process for equation 2. I'm going to plug in -1 for x and 3 for y. Right, this gives us 9 equals to 9, so that means that that -1, 3, the point is a solution to the systems of equations, which is equation 1 and equation 2. Okay, now I'm going to repeat the process for number 2. I'm going to plug in 2 for x and -0.5 for y. So again, we have equation 1 and equation 2. So, so I'm going to plug in 2 for x and -0.5 for y. Let's evaluate the left side. So that gives us -3 equals to -3, right? So then we can continue. If this was not true, right, say on the left side, we got like a -1, then we stop there and we say it's not a solution, that the point 2, -0.5 is not a solution. But since it's true, we continue to equation number 2. Again, x is 2 and y is -0.5. So after we do the simplify on the left side, it's going to give us -0.5 equals to -5, which is not true, right? They're not the same. They're not equal. That means that the point 2, -0.5 is not a solution of the systems of equations. So number 1 was a solution, and number 2, not a solution. Okay. Now let's do the next slide, right? So now we're going to be solving systems of equations by graphing. So by graphing, we have to graph both equations 1 and 2, right? We have to graph both of them, and then the answer or the solution will be where they both intersect, where the lines intersect. Okay, now graphing, I believe you already covered this and I believe in chapter 1 or chapter 2. Okay, so to graph in the form y equals to mx plus b, the 3 is my slope, right? So it's going to be the rise over the run. And the b is my -6, which is equivalent to the y-intercept, which is equal to 0, -6. So this is my starting point, okay? So the b is my starting point, or the y-intercept is my starting point. So 0, -6, we're going to go to the y-axis. We're going to go all the way down here to -6. And then the slope is +3, +3, 1, right? So we're going to go up 3, 1, 2, 3, and 1 to the right. So my point should be there, right? And if we continue in the same fashion, it's going to be the same line. So this is the graph for equation number 1. Now, we have to do the same thing for equation number 2. So let's keep it uniform. Let's put equation 2, let's set it up in the form y equals to mx plus b, which is called the slope-intercept form. So I have to isolate the y. Okay, so first, we start by adding 5x to both sides. Right, so we're going to get -2y equals to 5x minus 10. And then we divide all terms by -2, or both sides by -2. So y equals to -5 over 2x plus 5. So what's my slope? My slope is -5 over 2. And my b, which is a y-intercept, is 0.5. So again, 0.5 is going to be my starting point. So I have to go to the y-axis, which is the vertical hairline. This is a y-axis. So we're going to go to 0, 5. 0, 5 will be all the way up here. That's my point 0, 5. Then I'm going to go down 5, right? Because this is my right. So I'm going to go down 5 and 2 to the right. Or I could have gone 5 up and 2 to the left, you see, but if we go 5 up, it's going to be off the grid. That's why we're going to use the numerator as negative and the denominator as positive. So again, we're going to go down 5 from the point 0, 5. So 1, 2, 3, 4, 5, and 2 to the right. 1, 2. There's my point. So we draw our line. So the answer is where they intersect. If you see that, they intersect at the point 2, 0. So that's my solution, 2, 0. Okay. So this is how you solve systems of equations by graphing. You have to graph both equations, and where the lines intersect, that's your solution. Now, let's do the very same ones, very same systems of equations, but let's do it by substitution. Okay, when the instructor states in the instructions, solve by graphing, you have to do it by graphing. If they state solve by substitution, we have to do it by substitution. And if they state solve the system by elimination, well, you have to solve it by elimination. You have to follow what the instructor states. And if there's no instructions on how to solve it, you use whatever is easier for you. Okay, so after I explain the 3 methods, and if they're not specific on how to solve it, you use what's easier for you. Okay, so for number 4 here, solve by substitution. Well, again, this is equation 1 and equation 2. So we have to isolate one of the variables. Okay, so in equation 1, the y is already isolated. So I'm going to use 3x minus 6 and plug it in for the y value on the second equation. Okay. So again, right, because the y is already isolated, so I'm going to substitute 3x minus 6 for y, which is right here for the y's. So I'm going to put in 3x minus 6, and then I just distribute. Okay. So they will give us negative 5x minus 6x plus 12 on the left side equals to negative 10. Now I'm going to combine like terms. Like terms are the x, right, are the x's, right? So negative 5x minus 6x will give us negative 11x plus 12 equals to negative 10. Now all you do is solve a simple one variable equation, which means that I have to get the x by itself or isolate the x. So I'm going to subtract 12 to both sides, from both sides. So if we do that, we're going to get negative 11x equals to negative 22. Then we divide by negative 11, both sides. So it's going to give us x equals to 2. So once you get the x value, right, we need to find the y value. So then we have to go back to equations 1 or 2 and plug in the value 2 for x and solve for y. But it depends on what's easier for you. Okay? In my opinion, it's easier to go to equation 1 because a y is already isolated. So all we need to do is plug in the 2 for x and simplify, and we got the value for x. For y. Okay? Since x is 2, I'm going to plug in the 2 for the x. So y equals to 6 minus 6, y equals to 0. So my solution, x is 2 and y is 0. That's my solution. Okay? And you can always go back and check it. Remember the first or the second slide that I covered to determine solution or not? You can plug in 2 for x and 0 for y on both equations, and it has to be true for both. That's how you can check your work. Okay, now let's do one by the elimination method. This is a little bit different. I believe when I cover this section, I believe I use the same system for all three for graphing, substitution, and elimination. And this is a little bit different, okay, guys? But anyway, this is the concept here. I say solve by elimination. Okay, this is equation 1 and equation 2. So to solve by using the elimination method, both equations must be in the form ax plus by equals c. If you notice, equation 2 is already in that form. right? 4x minus 3y equals to -1, but equation number 1 is not. So I need to rewrite equation 1 in the proper form. So I'm going to add 2y to both sides. That gives us x plus 2y equals to 19. Now it's in proper form, in the form of ax plus by equals c. In some textbooks, they call this the general form, but in this textbook, they just say the rule. Okay, so what rule? The rule of ax plus by equals c. That's why I just put the form, not the name of it, okay? So now, right, so now we put them together. Now, here, it depends what you're going to get rid of. You want to eliminate the x's or the y's. So here is where it's up to the student. Again, in my opinion, it will be easier to eliminate the x's because all I do is multiply -4 times equation number 1. This way, -4 times x will give us -4x. Then when I add it to equation 2, the x's will be eliminated. Okay. So I'm going to multiply by -4. And again, why -4? Because this is already a positive 4 there. So -4 times x will give me a -4x. And then when I add them, they'll be eliminated. But you have to use legal math concepts here. So I need to multiply -4 times both sides of the equal sign, or -4 times every term on the equation. So if we multiply -4 times x and -4 times 2y and -4 times 19, the result will be -4x minus 8y equals to -76. Now equation 2, all we do is bring it over how it is. You see, now we're going to add them. So the x's will be eliminated. -8y minus 3y will give us -11y. And -76 minus 1 will give us a -77. Then we divide both sides by -11. So we get y equals to 7. Okay, again, like the previous slide where we're doing it by substitution, right? Now it's going to be the same thing as the other slide. We have the value for y. Now I need to find x. So I'm going to plug in 7 for y in either equations 1 or 2. And again, whatever is easier for you. Again, my opinion, it'll be easier to plug it in equation number 1 because the x is already isolated. You see? So I'm going to plug in 7 for y. So I'm going to plug it in right there. So -2 times 7 will give us -14 plus 19 will give us 5. So we have x equals 5 and y equals 7. This is my solution. If you have any questions as I go along, please raise your hand up, and Ms. Patricia would, or Alden would tell me that there's a question, and that way they'll stop me, because when I'm showing my screen, I don't see who has any questions. Okay, so again, if you have any questions, please raise your hand up so I can assist you, right? Or I can give you clarification before I keep moving on. Now, this is number 6. Again, solve the system by elimination. At times, guys, there's no solution on a system, which means perhaps the two lines are parallel. They never intersect. Or another instance or another case might be that it's the same line, like the line is on top of the line, which means it's going to be infinite solutions. And I believe number 6 and number 7 are going to be an example of each one. Okay. So for example, here on number 6, equation 1, equation 2. So again, I need to get rid of the x's or the y's. So here, if we multiply -2 times 3x, will give us a -6x. And then when I add them, they'll be eliminated. Okay. So multiply by -2. This gives us -6x plus 4y equals to -8. If you notice, everything will cancel, or be eliminated on both sides of the equal sign. So 0 equals 0, right? So this is true, right? Isn't this true? 0 equals 0. That means that it's going to be infinite solutions. That'll be the result. Okay. Now on number 7, we have another system of equations. So again, I'm going to get rid of the x's by multiplying the first equation by -3. Okay. So after I multiply -3 times every term on equation number 1, it's going to result in -6x minus 15y equals to -24. we just bring equation number 2 over. So after I do the operation, right, so negative 6 plus 6 will cancel, will be 0. Negative 15y plus 15y will give me a 0. On the right side, negative 24 plus 18 will give us a negative 6. So 0 equals to negative 6, right? And that's not true. That way, that means that these two lines are parallel. They will never intersect. No solution. Okay? That's how we do these types of solving systems of linear equations. Okay. Okay. Now, here's we continue with 6.1. Here's how it applies to a real life situation. Okay, like an applications problem. Here it states a 200-seat theater charges $8 for adults and $5 for children. If all seats were filled and the total ticket income was $1,435, how many adults and how many children were in the audience? Okay, well, let's find out. So here, guys, the main objective for these types of problems, you have to find two equations, okay? And then solve it by either graphing, substitution, or the elimination method. In my opinion, guys, the elimination method is easier, so that's what I'm going to be using, okay? But you can use any method you want. So what's equation 1? Okay, so this is what I tell my students. We're going to do seats with seats or people with people and money with money. What does that mean, right? So for example, I'm going to let X, because it's first, right, equal to the adult tickets. And let Y equals for children's tickets, because I want to keep using the same variables, X and Y, or you can use A and C. A stands for adults and C stands for children, right? But I'm going to keep it uniform by using X and Y. And there were 200 total seats. So this equation will be X plus Y equals to 200. Now, money with money, okay? So if the adult tickets are $8, so this will be represented by 8X. In a similar manner, if children's tickets are $5, this will be represented by 5Y. And what was the total ticket income? Was $1,435. So that must equal to $1,435. So we got equation number 2. 8X plus 5Y equals to 1,435. Now let's put them together, equation 1, equation 2, and let's solve them, or let's solve the system by using the elimination method. So here I'm going to get rid of the x's by multiplying equation number 1 by negative 8. Now if I multiply negative 8 times x and negative 8 times y and negative 8 times 200, the result is negative 8x minus 8y equals to 1,600. Now equation number 2, all we do is just bring it over, right? Then you see, if you notice, the x's will be eliminated. So, but negative 8y plus 5y will give us a negative 3y, and negative 1,600 plus 1,435 will give us negative 165. So we divide both sides by negative 3, and the result will be 55. Now, we can go back to equations 1 or 2, right, and plug in 55 for y, another equations 1 or 2, but in my opinion, the equation 1 is easier, you see, because the values are very, very small, or the coefficients very, very small compared to equation number 2. So I'm going to go back to equation number 1. I'm going to plug in 55 for y, and, right, so we get x plus 55 equals to 200. We subtract 55 to both sides, and the result is x equals to 145. So x equals to 145, y equals to 55. You see, but that wasn't the question. The question was how many adults and how many children were in the audience. So if we go back, right, we let x equals to adults, so it's going to be 145 adults, and 55 children were in the theater. So this is my solution. Okay, now let's do 6.2. This is larger systems of linear equations. So you're going to go from, right, so this is, these are 3 variables, x, y, and z, right? So we call it equation 1, equation 2, and equation 3. I always tell my students that it's always wise to put equation 1, right? You can swap them around, or right? I always want to have a coefficient of 1 on the x for equation number 1 because it makes the work much easier. Okay. So this is a plan. I'm going to get equations 1 and 2 and get rid of the x's. And then I'm going to get equations 1 and 3 and also get rid of the x's. Okay? And I believe I did a presentation about 2 weeks ago. And it tells you the plan, right? But here, let's assume, because I'm going to assume that you already went over the PowerPoint 2 weeks ago, and it tells you the steps here. Okay, so I'm just going to execute the steps. So again, I'm going to get equations 1 and 2. Now, you see, because we have a 1 here, right, for equation 1, it'll be easier to get rid of the x's on equation 2, because all we do is multiply the whole equation by -2. And again, why -2? Because we want the x's to be eliminated, and the only way it can be done so is we multiply the whole equation by -2, because -2 times x will give us -2x. Then when we add it to 2x, the x's will be eliminated. Okay. So after I multiply -2 times every term in equation 1, the result is -2x plus 6y minus 4z equals to 0. Then equation number 2, we just bring it over and we just add them, right? So this will give us 0. This will give us 4y minus 3z equals to 3. So this is considered my new equation 2. Now I repeat the process, but instead of 1 and 2, I'm going to use 1 and 3. And again, we're going to get rid of the x's. Okay, and again, right, it's easier because we have only an x here. So we multiply equation 1 by -3. So after I distribute, right, we're going to get -3x plus 9y minus 6z equals to 0. We just slide equation number 3 over and we execute the operation. The x's will be eliminated, but we're going to have 10y minus 7z equals to 7. Right, so that's considered my new equation 3. If you notice, guys, we don't have no more x's on equations 2 and equation 3, right? So now the plan is that we're going to get the two new equations 2 and 3, the new equations, and we're going to get rid of the y's. Okay, now to get rid of the y's, at times some instructor or the book might say something like find the least common multiple, which is 20, right? But I'm going to assume, I would like to assume that the students don't know nothing. This way, I explain like if they didn't know anything, right? And then whatever they know will be to their advantage, because my always as I teach, I don't want no student to fall behind. This way, I like to always assume that students don't know nothing and take it from there. So, for example, so instead of finding the LCM, right? Because the LCM is 20, right? But if I try to get the LCM, the least common multiple, and students don't know what it is, they're going to be confused. So in other words, I'm going to use how they are. The setup how it is. So we want to get rid of the y's, right? So I'm going to multiply 1 by a negative number because they're both positive, right? So I'm going to multiply equation number 2 by -10 and equation number 3 by 4, right? Because -10 times 4y will give us -40y, and 4 times 10y will give us +40y, and they'll be eliminated. But again, I need to use math concepts, legal math concepts, so I need to multiply -10 times every term on equation 2, and 4 times every term on equation 3. So after I multiply -10 on equation 1, this is a result, -40y plus 30z equals to -30. And if I multiply 4 times every term on equation 3, it's going to give us 40y minus 28z equals to 28. So after I execute the operation, it's going to give us 2z equals to -2. So we have to solve for z, right? So we divide both sides by 2. So the result will be z equals to -1. Now I'm going to use substitution. Okay, I'm going to go back, right? So if you want, you can set up the equations. You can get any one of the equations here, right? But I'm going to keep equation 1. Then I'm going to go back to the new equation 2 or the new equation 3, right? But I'll just follow the format, and I'm going to go to my new equation 2 and use that. And then lastly, we got z equals to -1, right? Now I'm going to go back and back substitute. So I'm going to go back to equation number 2, and I'm going to plug in -1 for z. Okay, because z equals to -1. So after I plug it in there and I simplify, it's going to give us 4y plus 3 equals to 3. We subtract 3 to both sides. So we get 4y equals to 0. We divide by 4. So we know that y equals to 0. So I already have the values for y and for z. Then I go back to equation number 1. I'm going to plug in 0 for y and -1 for z. Right? So the y is going to be 0 and the z is going to be -1. So this will give us x minus 2 because -3 times 0 will give us 0 and 2 times -1 will give us -2. Now we're going to add 2 to both sides. So x equals 2. So I already solved the system, right? The answer is x equals 2, y equals 0, and z equals to -1. If you follow my format, you can never go wrong. Just follow, the steps here. If you want, go back and watch the video, the recorded video from 2 weeks ago, and it explains more in detail. But you can never go wrong if you follow this format, okay? Okay, now, this is the Gaussian elimination method. Okay, now, this is another way to solve the system. Okay, so we're going to get, right, so I believe it's the very same one. This, in our Minty matrix, we only get the coefficients, right, which is 1, -3, and 2, and 0 on top. Then it's going to be 2, -2, 1, and 3. And 3, 1, -1, and 7. And then after you apply the reduced row echelon form, this is the way it should look when you're done, right? So this is a value, this is our x column, the y column, and the z column. So then x equals to 2, y equals to 0, and z equals to -1. But how? So that's what I'm going to show you. Most instructors do not give this on the exam for the reason why is that this can take a long time for students to actually work it. And most of the time, students are confused on how to solve it. So that's why most instructors don't give it on an exam, and neither do I. But it's good to know if you're taking the next course for this from 1324, which is 1325, because you need to know this if the instructor has the option to teach some of the sections for chapter 7. So for chapter 7, if the instructor chooses that option, because it's optional for the instructor to teach chapter 7, and if he does, you gotta know. You gotta know this topic here. Okay, so I'm going to explain it anyway, just in case some instructors actually do assign it. So this is, I call it the three-step plan in action. Okay. So for the first step, okay, and also I'm going to show you later how to plug in the calculator to get the result. But I always ask my students to show me the work. Okay, so first let's do it by showing the work. So this is the first step here. Okay, this is considered row 1, and then row 2, and row 3. So the objective here for step 1, right? For step 1, we keep row 1. So the 2 has to be a 0, and the 3 must be a 0. We see this is color coded. The blues, right, is first step. The greens is going to be in second step, and the red will be the third step. So for the first step, the 2, right, must be a 0, and also the 3 must be a 0, which means I got to change row 2, and I got to change row 3 by using row 1. So I'm going to multiply -2 times row 1 and add it to row 2. And then I'm going to multiply -3 times row 1 and add it to row 3. Okay, now here's my work. So -2 row 1, right? -2 row 1 is going to be -2 times the coefficients on row 1. So after I multiply -2 times 1, negative 3, 2, and 0. The result is negative 2, 6, negative 4, and 0. And then we're going to add it to row 2. All right? So after we execute the operation, it's going to give us 0, 4, negative 3, and 3. So this becomes my new row 2. Now I'm going to do the second step, right? The second part of step 1. So I'm going to multiply negative 3 times row 1. So it's going to give us negative 3, 9, negative 6, and 0. So we just bring row 3 over. And after I execute the operation, it's going to give us 0, 10, negative 7, and 7. So that's my new row 3. Now on the next slide, I'm going to continue with row 2. Okay, and again, remember the plan here, or the objective. Now I'm going to do step 2, right? Because step 1 is already executed, because the goal was to make these, on the first column, second and third row be equal to 0, you see, like the plan here. Now, the negative 3 must be a 0 and also the 10 on column number 2. So step 2 has 2 parts, A and B, right? So I'm going to keep row 2. So again, when we use step 1, we keep row 1. When we use step 2, we keep row 2. Now the negative 3, right? The negative 3 has to be a 0. So that row 1 has to change. And also the 10 must be a 0. So that means that row 3 is got to change, right? Because we want these to both be zeros, as you see here at the objective in green here, the zeros in green. So here I have to multiply. For example, here, right, we have negative 3 and we have 4. One's negative, one's positive. So I'm going to multiply 4. I'm going to multiply 3 times row 2 and add it to 4 times row 3 times row 1. You see? So, and then here on the bottom right, again, we have 4 and 10. So I'm going to multiply, negative 10 times row 2 and add it to 4 times row 3. Okay, and here's my work. So 3 row 2, right? 3 row 2 will give us 3 times row 2, and row 2, right, was 0, 4, negative 3, and 3. This is going to give us 0, 12, negative 9, and positive 9. Then when added to 401, I'm going to multiply 4 times all the coefficients on row 1, which will give us 4, negative 12, 8, and 0. So after I execute the operation, we get 4, 0, negative 1, 9. So that's my new row 1. Okay. Now, I'm going to do the part B on step 2. So negative 10, row 2 will give us negative 10 times 0, 4, negative 3, and 3. Which the result is 0, negative 40, 30, and negative 30. Now we're going to add it to 4 row 3. So 4 times row 3. So it's going to give us 0, 40, negative 2, negative 28, and 28. After we execute the operation, we get 0, 0, 2, negative 2. And we always simplify to make it easier, right? Because we want that to be a 1, right? We want this to be a 1. So we divide everything by 2. So this is my new row 3. Okay, and again, step 2 is already executed because the second column on the first row and third row are already zeros. Now let's go to step 3. So step 3, right? Again, step 3, we're going to keep row 3 how it is. So the place on the first row, third column, the negative 1 must be a 0. And on the on the second row, third column, the negative 3 must be a 0. So row 1's got to change, and also row 3's got to change by using, row 2, by using row 3. So if you notice, we already have a 1 here, right? And we have a negative 1 there. So all we do have to add row 3 plus row 1. And here we have a 1, right? And a negative 3. So I need to multiply row 3 times 3. And add it to row 2. And here's my work. This is going to give us 4008. So we simplify. If we keep simplifying, the maximum matrices that you're going to get is 4, right? We have 1, 2, 3, but most of the time it's going to be 3. But just in case these this wasn't able to simplify, we wait to the very end and we do another matrix. But like most of the times, if you apply the method that I'm showing you, you only have 3 steps at the most. Okay, I mean mostly always 3 steps. I mean 3 steps, but both steps have parts A's and B's. So this is my new row 1. Now here's our work for part B of step 3. 3 row 3 will give us 0, 0, 3, negative 3. And then we add it to row 2. All we do is bring row 2 over. So after you execute the operation, it's going to give us 0, 4, 0, 0, right? But that we want to make that a 1. So we divide everything by 4. So we get 0, 1, 0, 0. So that's my new row 2. If you notice, we accomplished a task, right? Because all the ones diagonally, these have to be ones diagonally, and the rest have to be zeros, right? Which we just did. Which means this is the X column. The second column will be the Y column. The third column will be the Z column. So we got X equals to 2, Y equals to 0, and Z equals to negative 1. So here's my solution. There we go. Okay. Okay, now let's do one together. Just kind of quick, right? So again, step 1, we want to make the 2 and the negative 1 zeros, right? So row 2's got to change, and row 3's got to change. Every time that I'm explaining this topic, I tell my students that they cannot go to the restroom, they cannot even blink. I mean, I'm just being sarcastic, right? Which means they have to be paying attention for them to actually grasp the concept. Because at times, when I first started teaching this course, I would go with the material. This would take about an hour for students to really kind of understand it if they follow. And at times, students didn't even understand it because they weren't paying attention, or maybe they lack the attention span. Because it takes you really have to concentrate. So, but if you have this PowerPoint, right, or this video, you can pause it and go slow until you fully understand it. So this is what I use when I teach now. I like to use this PowerPoint here because I can explain it, and the students can go over it at their own time. So again, right, so the rule is that the 2 on row 2, the first column must be a 0 and also the negative 1. So I'm going to multiply negative 2 times row 1 and add it to row 2. And since row 1, the first column is already a 1, and row 3, the first column is already a negative 1, so all I do is just add those 2 rows. And here's my work. Right, so negative 2 row 1 is going to give us negative 2, negative 4, 2, and negative 12. And then we're going to add it to row 2. So we just bring row 2 over. So it's going to give us 0, negative 5, 5, and negative 10. So here, if you put this as row 2, right, then these are the numbers are too big. That's why if you can simplify them, you do it as you go along. So for example, you can divide everything by negative 5. If we do that, we get 0, 1, negative 1, 2. So that's my new row 2. And I always encourage my students to simplify if they can as we go along to eliminate the real big numbers. So now we're going to do row 1 plus row 3. So it's going to give us 0, 1, 0, 1. So that's my new row 3. Now step 2, right? So step 2, we keep row 2 how it is. So the first row, second column, the 2 has to be a 0. So that's going to change. And also the third row, second column, the 1 has to be a 0. So row 3's got to change. That's why I put the arrows, where there's going to be some type of execution to eliminate, to make those 2 zeros. So again, I'm going to use row 2. So I'm going to multiply negative 2 times row 2 and add it to row 1. Since these 2 are already 1s, right? But they're both positive, so I'm going to multiply negative 1 times row 2 and add it to row 3. And here's the work. Okay. So after I multiply negative 2 times row 2, it's going to give us 0, negative 2, 2, and negative 4. Then when I add it to row 1, right, we get 1, 0, 1, 2. So that's my new row 1. So negative 1, row 2 is going to give us 0, -1, 1, and -2. Then when I add it to row 3, it's going to give us 0, 0, 1, -1. So that is my new row 3, and I'm done with step 2. Now the last step, we have to make row 1, column 3, a 0, and row 3, column 3, where the 1 is, also a 0. So we're going to use row 3, so it stays the same. So the 1 on the first row must be a 0 on column 3. So that whole row is going to change. And also the second row, third column, where the -1 is, that also has to change because they'll have to be zeros. So that's why we put the arrow where the change is going to take place. Okay, now we have 1 and we have +1, right? So they're both positive, so we cannot add them because they're going to give us 2. So I'm going to multiply -1 times row 3 and add it to row 1. And then for the second step here, right, that's a +1 and a -1, right? So all we have to do is just add them. So it'll be row 3 plus row 2. And here's my work. So after I multiply -1 times row 3, it's going to give us 0, 0, -1, and 1. Then we'll just bring row 1 over, right? So after I execute the operation, it's going to give us 1, 0, 0, 3. So that's my new row 1. So row 3 plus row 2 is going to give us 0, 1, 0, 1. That's my new row 2. If you notice, we're done because these are all ones diagonally, and there was just zeros. So the solution is x equals to 3, y equals to 1, and z equals to -1. That's my solution. Okay. Okay, now how do you apply that problem or these type of problems in a real life situation? It's going to be very similar to the one that we did earlier. Also that applications problem, but only with 2 variables. Here we're going to have 3. So what's my solution? I need to find 3 equations. So again, we're going to use people with people, right? Because here they're talking about adults, teenagers, and preteens. So people with people and money with money for the first 3 equations. Okay, here we go. So since adults are first, I'm going to let that equal to x. Teenagers are second, I'm going to let y equal to teenagers. And then lastly, since we have preteens, so I'm going to let z equal to preteens. And there were 570 total people. So my equation 1 will be x plus y plus z equals to 570. Now let's do the money with money. So adults, right, is cost $5. So it's going to be 5x. And then for the y, right, represents teenagers, right? So we have $3 for teenager tickets, so that's going to be 3y. Then we have $2 for preteens, right? And z represents preteens, so it's going to be 2z. And what was the total revenue or the total receipt or the total money was 1,150. So we have equation number 2, which will be 5x plus 3y plus 2z equals to 1,150. Right, but we're missing equation number 3. Okay. So now we're going to use the second to last sentence to find equation number 3. Okay, this is always a little bit complicated for the students. Okay, but I'm going to show you a technique that I learned that works. Okay, so for example, 3/4 as many teenagers as preteens attended. So this is right. We know that teenagers are y and preteens are z. So this is what it should be. Okay, but at times, right, it doesn't sound like that. So like I tell my students, if it's difficult, write it how it sounds, and then switch the variables from y to the z. Okay, Mira, for example, or maybe I'm using the wrong wording here. Okay, but I believe last time I used flip it. Okay, but I think the wording is not correct. But let me show you what I mean. Okay, hey, doesn't it sound like this? 3/4 as many teenagers, right? And then y represents teenagers, so 3/4 y equals to preteens. And then switch the coefficient from the y to the z. You see, and that would actually work. That would actually work if you apply, if you do it like this, write it how it sounds, and then switch the variable to the other side. Okay. Now, so we don't want fractions, right? So let's multiply both sides by 4 to eliminate the fraction on the right side where the z is, right? So it's going to give us 4y equals to 3z. So we have to put it in the proper form, right? We have to let it equal to a constant. So we're going to subtract 3z to both sides. And there's equation number 3. Okay. Now, I believe here where you continue. So here you could do it by using the Gaussian method. But I believe doing it the way that I showed you when you have 3 equations, right? I believe when you have linears of equations, you can do it by using equation 1 and 2 and 1 and 3 and get rid of the x's, like I did the first problem with three variables. Or if you want, you can use the Gaussian method. Okay. Here I'm going to use what I did earlier. I'm going to get equations 1 and 2 and get rid of the x's. So I'm going to multiply by -5. So after I do that, after I multiply -5 times every term, we get -5x minus 5y minus 5z equals to -2,850. Equation number 2, we just slide it over. After we execute the operation, it's going to give us -2y minus 3z equals to -900. This cannot be simplified, right? Because we'll get a fraction. So we'll leave it how it is. This is my new equation 2. If you notice, equation 3 is already with no x, so we don't have to do that step, right? So we can just keep equation 3 how it is. Now let's get rid of the y's. So I'm going to multiply equation number 1 by 2. Why 2? Because 2 times -2 will give us -4, and if we add it to 4, they'll be eliminated. Okay. So after I multiply 2 times every term in equation 2, we get -4y minus 6z equals to -1,800. We just bring equation number 3 over. So the result will be -9z equals to -1,800. We divide both sides by -9. So we get z equals to 200. Now let's go back and substitute. So, right, so let's go back to equation 2. Let's plug in 200 for z. So we get -2y minus 600 equals to -900. We add 600 to both sides. So it becomes -2y equals to -300. We divide both sides by -2. And the result is y equals to 150. Now I have my y and z. So I'm going to go back to equation 1 and plug in 150 for y and 200 for z. Okay, after I add them, it's going to give us x plus 350 equals to 570. We subtract 350 from both sides. So x equals to 220. So x equals to 220, y equals to 150, and z equals to 200. But again, that wasn't what we're looking for, right? They want to know how many adults, teenagers, and preteens are in the concert. Okay, so there's going to be 220 adults, 150 teenagers, and 200 preteens. Okay, now let's do 6.4. 6.4 is matrix addition. Okay, so to add or subtract matrices, they have to be the same size. So this matrix is a 2 by 3, right? Because we have 2 rows and 3 columns. Matrix B is also a 2 by 3. Matrix C is a 2 by 2, and matrix D is a 2 by 2. Okay, so here they want you to do A plus B, right? So A is a 2 by 3, and B is a 2 by 3. So this can be done because they're both the same size. So it's going to be 5 plus 2, and then -1 plus 0, and 6 plus 1, and then 3 plus -3, 4 plus 1, and -2 plus 4. So after we simplify, it's going to give us 7, -1, 7, 0, 5, and 2. So this is the solution for matrix A plus matrix B. How about C plus D? Right, so again, C is a 2 by 2 and D is a 2 by 2. So yes, it can be done. So 3 plus 2, 1 plus negative 1, negative 5 plus 8, and 0 plus negative 6. So the matrix C plus D equals to 5, 0, 3, negative 6. That's my result. Now, how about C plus A, right? C is a 2 by 2 and A is a 2 by 3. So this cannot be done because they're not the same size. Okay. Now let's do subtraction. Again. Okay, so those are the sizes. So A minus B will be 1 minus 8, and this can be done because A and B are the same size. So 1 minus 8, negative 3 minus 0, and 2 minus 1. And 2 minus negative 1, 2 minus 3, and negative 1 minus 4. Okay, so that will give us a negative 7, negative 3, positive 1, positive 3, negative 1, and negative 5. Now C minus D, again, it can be done because they're both 2 by 2. So 5 minus 2, 1 minus negative 1, negative 4 minus 9, and 3 minus negative 7. So this becomes 3, 2, negative 13, and positive 10. That's my result of matrix C minus matrix D. Now A minus C, right? A minus C, it cannot be done because A is a 2 by 3 and C is a 2 by 2, not the same size. Okay, now matrix operation, right? So now we're going to multiply. I know this is a scalar. A scalar means that there's a coefficient in front of the matrix. So for example, negative 4a, we're going to multiply negative 4 times every element in A. So it's going to be, right, so negative 4 times negative 2, negative 4 times 0, negative 4 times 5, and negative 4 times 3. And again, guys, you can go straight to the answer, guys. I just show you this step here so you can see exactly what's taking place. But you can go negative 4 times negative 2 will give us an 8. Negative 4 times 0 will give us a 0. Negative 4 times 5 will give us a negative 20. Negative 4 times 3 will give us a negative 12. Okay. Now let's do 5 times b. So again, 5 times b will be 5 times every element in b. So it will be 5 times 0, 5 times 2, 5 times 4, and 5 times negative 6. So 5 times 0 will give us 0. 5 times 2 will give us 10. 5 times 4 will give us 20. And 5 times negative 6 will give us negative 30. So that's the result of 5 times matrix B. Now for C, right, we have negative 4a plus 5b. We already executed negative 4a on problem A. We already executed 5 times matrix B on problem B. So now all we do is get the solution from both and add them, right? This was negative 4a plus this was a solution for matrix 5 times B. So now it's going to be, so negative 4a plus 5b will give us 8 plus 0, 0 plus 10, negative 20 plus 20, negative 12 plus negative 30, and here's my result, right? So 8 plus 0 will give us 8, 0 plus 10 will give us 10, negative 20 plus 20 will give us a 0, and negative 12 plus negative 30 will give us a negative 42. So that's my result of negative 4a plus 5b.
I think Mr. Zassi just lost connection. When he comes back in, we'll have him go up to the top. It looks like it, Antonio. Unfortunately, I wasn't able to see your question in the chat because the link didn't work for me. So I apologize for that, Antonio. If he doesn't come back in a minute or two, then I guess we'll have to wrap up because Mr. Azasi shares his screen, so I can't continue. Got you. Applications of matrices. As soon as he comes back, hopefully. Let me go ahead and I'll wrap up since we seem to be out of time, almost out of time on this session. If Mr. Azasi comes back, for sure we'll let him finish up, but if not, his computer might have died or something, and so in which case he won't be able to finish in a timely manner for the recording. So next week, oh, that's today's session. I apologize. I pulled up the wrong one. So next week, we're not going to have a TVE because it is going to be, I believe it's Labor Day. Alan, can you help me out here? Is it Labor Day?
It should be Veterans Day.
Veterans Day. I'm so sorry. Okay. So Veterans Day, and so therefore we won't be having a TVE next week. However, we will be back on November 18th, and for Math 1324, they'll be going for exam review 3. So please come back then. Thank you for joining us today, and we hope you have a wonderful weekend.